Hi everyone, my name is Danny Vole from the Swinburne node of ADACS, the Astronomy Data and Computing Services. This is a short webinar on the Table Access Protocol from the International Virtual Observatory Alliance. This tutorial is structured as follows. First, we will cover motivations and background information about the Table Access Protocol, or TAP, in the context of the Virtual Observatory. Then we will describe TAP via a service description, the TAP schema, the ADQL language, and the query processing. And finally, we will finish with examples of TAP implementations in two different applications, TopCat and PyVio. This webinar is based on the following resources, which I invite you to browse for further details. In the last decade, the amount of data in astronomy has rapidly increased, helping astronomers to put constraints on physical processes and open new research opportunities. The price, however, has been that astronomy data is now heterogeneous in every sense of the word. Data is taken by different instruments at different wavelengths. We have to deal with many types of data, images, spectra, and so on, and also deal with different units. Plus, data is distributed over the world and stored in various ways. For instance, in relational database management systems, on file systems as raw files, and also using different formats. To take full advantage of what is available, we need to gather and combine all of the data. For instance, when we want to study their properties, including colors and other physical parameters, we need to cross-match sources by positions from different catalogs. This can be challenging due to the heterogeneous nature of the data. This is the main motivation to have a standard procedure to share and access data. For this reason, in 2002, the IVOA was formed to unify access to datasets, resources, and services via the Internet. The IVOA used various standard Internet protocols as a basis for its protocols, for instance the HTTP and XML standards. The IVOA designed and proposed several web service protocols to access different kinds of data resources, such as the Simple Cone Search Protocol, Simple Image Access Protocol, and the Simple Spectral Access Protocol. These are called simple because they are dedicated to one type of data and have a limited query parameter interface. The emergence of these web services also led to the development of various client tools with simple and user-friendly interface, such as TopCat and Aladdin. The development of virtual observatory clients and other specialized clients showed that simple protocols do not allow for heterogeneous data access, offer only restricted query capabilities, and have limited data description capabilities. The proposed solution was the more flexible protocol called TAP. It is a flexible yet standard access to different kinds of databases, and also aimed to unify clients' development. TAP defines a service protocol for accessing general table data, including astronomical catalogs, as well as general database tables. Access is provided for both database, table metadata, and table data. TAP includes support for multiple query languages, including queries specified using the Astronomical Data Query Language, or ADQL, and supports synchronous and asynchronous queries. Special support is provided for spatially indexed queries using the spatial extension in ADQL. The VO Data Access Layer, or DAL, provides protocols that standardize access to data. For example, the VO table is based on XML and can contain both metadata and results data in one single structured document. These standards are supported by TAP. VO protocols distinguishes between tabular and non-tabular data. Tabular data corresponds to a key-value pair, which is extracted from data files and stored in tables, where one column includes all values for a specific keyword. Non-tabular data generally corresponds to n-dimensional arrays, such as spectra, images, and data cubes. To put this in context, the following example illustrates a typical VO sequence of data discovery. The user needs a simple way to find the services which deliver VO-compatible data. This is done by querying the VO registries, which provide descriptions of types, availabilities, and capabilities of VO services, as well as the URLs of these services. After choosing the services, a user is now able to send appropriate queries. Tabular data is queried using ADQL. Querying tabular data with TAP in the VO is generally a two-step process. First, the service discovery. Second, Data discovery and retrieval. Generally, the responses are a list of measurements within the application or further research. Non-tabular arrays of values can be discovered using OBSTAP, or Observational Table Access Protocol. It can also be found using simple protocols. OBSTAP is a TAP service that can be queried using ADQL, where the response is a description of non-tabular datasets. OBSTAP is used to retrieve metadata of datasets, in particular the descriptions of data consistent with OBSCORE, the IVOA data model. Metadata embedded in the query response of these services can be displayed by your program. This provides a dataset discovery facility, where users can download the full dataset. On the other hand, simple protocol queries will provide similar capabilities. However, the query parameter interface is less advanced. Specialized protocols also allow direct access to data subsets without full data retrieval. Access to non-tabular data in the VO is a typically three-step process. First, service discovery. Second, data discovery and description. And finally, data retrieval.